Hello and welcome to this presentation. The aim of the following video is to discuss and compare different programming languages, and we will be focusing on languages which comply to the agent-based architecture. So if we take a look at the overview, first of all we will be introducing the concept of agent-based architecture. Then we will be looking at different types of agent systems, and next we will mention some of the most common programming languages used in this architecture and a few applications. So first of all, we will look at the agent-based architecture. This architecture was mainly developed for the simulation of large service systems. When we say service system, we are talking about a system focused on an execution of orders and the realization of services relating to them. Let's look at the definition of an agent. Basically, an agent is a computer system which is placed in an environment, and it is able to take independent actions according to the feedback received from its surroundings. Now, there are four main features associated with agents. The first one is autonomy, that is, the agent is entirely able to control its activities and in a status. The next one is social behavior, which means agents should be able to interact with each other as well as human beings. And reactiveness refers to an agent being able to respond to external influences. And proactiveness means that an agent is able to act with initiative and goal orientation. Another important feature is that agents are able to improve their behavior continuously, since they have the ability to learn, so their behavior improves with increasing experience. A little bit about the agent functions can be understood through this diagram. Firstly, a given task is assigned to each agent. The agent then goes through its defined life cycle, that is sensing, decision making, and acting. During this process, it uses the support of solving, which provides solution proposals, and communicating with other agents as well as with human operators. Now let's take a look at single and multi-agent systems. Basically, single agent systems have only one agent which is responsible for making the decisions. All other agents act as what we call remote slaves. This means all the other agents carry out whatever task instructed to them from the primary agent. In multi-agent systems, there are several agents, each with the ability to make their own decisions. And the important point in these systems is the need for the agents to communicate between each other so that they remain consistent in what they do. Now let's move on to discuss about a few languages that are following this architecture. One important point worth noting is that all these languages use a principle called BDI, which stands for belief, desire, and intention. This is the base from which the implementation of such languages are carried out. We will be briefly looking at Java, NetLogo, 3APL, as well as Prolog. Okay, let's take a look at 3APL. 3APL is an agent programming language based on the concept of an intelligent agent. The programming logic is a variant of a model language with operators and the beliefs of an agent. The programming language 3APL is a combination of imperative programming and logic programming. Beliefs and goals are the basic components on which all of 3APL and other languages like DMARS and AgentSpeak are based on. In 3APL, beliefs are formulae from a first-order language, and that is defined in the usual way. And the implementation of multi-agent system requires single-agent programming and multi-agent programming, such as which and how individual agents should be executed. And 3APL platform provides a user interface that allows 3APL agents to be programmed, loaded, and executed in the given environment. As you can see in the diagram A shows an architecture for the 3APL platform, and this includes all the external influences from the environment, that means the users and networks which interact with the 3APL architecture. And the diagram B shows the different components in a single agent, and this includes beliefs and goals and other parts of the agent which are considered important. And other issues that are concerning 3APL are software engineering issues, and these are modularity, abstraction, and reusability. Modularity is the implementation of an agent in the sense that an agent can be implemented in terms of quite a number of different modules. And abstraction implies the introduction of plan revision rules. And finally, 3APL platform allows reusing multi-agent systems by providing a library of templates for individual agents and templates for multi-agent systems. Next one is Jade language. Jade is more of a framework which provides an environment to build agent-based systems, especially for managing network-oriented operations. The operation of Jade is based on a number of principles which enables its functions. These are interoperability, uniformity, and portability, which is one of the important features needed for effective communication over the network. It also provides good abstraction, which makes it easy to use, and it follows the pay-as-you-go philosophy. As you can see in the diagram, this is the Jade framework, which is basically a layer between the set of agents and the different media which communicate with the agents in different ways. So the Jade is actually acting as an interface to provide communication between the agents and external influences. The next language is Jack, which is a platform which extends Java. It is considered mature and robust due to its increased capabilities. Now we will look at how Jack differs a little bit from Java. Jack can add new top-level entities for declarations, and we will look at some examples in a moment. In addition, the properties and relationships of the top-level entities are also defined. And within the plan body, Jack defines a set of statements which it would be needing under certain conditions. This extract shows us statements, and you can Jack statements, and you can get an idea of what functions Jack has been designed to perform through the examples mentioned. Moving on, here are some examples of the top-level entities that is defined in Jack. So we've got the agent, belief set, view, event, plan, and capability. So all of these help the language to take independent decisions and serve its purpose. Another language is JADEX. JADEX is not based on a new agent programming language. Instead, a hybrid approach is chosen, distinguishing between the language used for static agent type specification and the language for defining the dynamic agent behavior. According to this distinction, a JADEX agent consists of two components: an agent definition file for the specification of beliefs, goals, and plans, and on the other hand, procedural plans.